basically what we want to do is to show that how people from different locations can interact.
On the comm air, we're the east, they're down around 12,000 feet. That's definitely not a comm air altitude.
We saw in the BFIT demonstration that you can take old equipment and new equipment, you can take Navy assets and Army assets, and you can network them together.
What we had was a naval gunnery training system in Norfolk, Virginia.
A Navy man-of-war floating in water but tied up in port.
We had the Marine Corps, and they were down in flying helicopters in Fort Rucker.
Linked with our site here at Fort Knox.
As a member on the net, we also had the Aegis Training Center.
A Fleet Combat Training Center, a node in Cambridge, Massachusetts, and a flying carpet or an observation mode as well in Washington, D.C.
And we all got together on a piece of the Fort Hunter Liggett, California terrain database and conducted a major exercise.
The point was to demonstrate connectivity among things that weren't designed to be connected.
Should be getting fire mission anytime now.
One of the neat things we were able to do, for example, would be to have a naval call for fire being called for by the Marine crewmen in the tanks here at Fort Knox and by the aviation crewmen who were flying the helicopters at Fort Rucker.
Okay, Bravo, we finally killed it. Roger.
As we flew over the USS Wasp icon that we saw in our screens, our signal showed up on their radar screens, which is an amazing feat when you think about it.
We had Army, Navy, and Marines all playing in the same network on their own systems. That's the first time that has ever been done.
Distributed Interactive Simulation.
BDSD.
Distributed Simulation Technology.
The DIS protocol.
SimNet.
CCTT.
The Virtual World.
The Synthetic Environment.
AirNet.
Artificial Reality.
The Virtual Battlefield.
What's common is they all use the same architecture. They all use the same standards.
Distributed simulation is not by any means the cutting edge of technology. None of this is exotic. Most of the equipment that you see on the floor here is off the shelf.
What's fundamentally changed is the movement toward networked interoperable simulation. It can be simulators or semi-automated force workstations or real equipment integrated into a kind of a single environment.
This architecture allows thousands of real and simulated elements to be connected in real time. In the future, it'll be possible to take things from hundreds of remote sites anywhere in the world, and then, once connected using a global grid, these elements can interact in synthetic environments. Basically, what this means is that you'll be able to create anything, from a synthetic battlefield to a synthetic factory, all using the same core technology.
Whether it's a $50 million dome flight simulator, a $250,000 simulator at Fort Knox, or a war gaming environment, don't throw it away because it's plug compatible in our warfighting environment.
Anything that you can conceive of can be put on a network. I'm talking about F-14s, strike aircraft carriers, Aegis cruisers, B-1s, F-15s, F-16s, early warning aircraft, tanks, Bradley fighting vehicles.
All the way down to the guy bringing lunch out to the troops.
In the early days when you brought the first guy in and you sat him down, he looked at it and he looked at the screens, he looked at the control and says, "This is not a tank." And we told him, that's correct, it's not a tank. And the soldiers would get in, and after about 30 minutes or an hour, they were immersed in a warfighting experience because they were interacting with people.
Get out of here, on the way!
Learning how to fight the aircraft is something totally different from learning how to fly. Every day you go up, you find something, ever so little it might be, you find some other way to use or enhance the way you use that aircraft. Here, it's not necessarily the aircraft itself, it's being able to use the terrain and being able to get that real-time feedback.
Remember, if you get too comfortable out here, you're not learning anything off of this.
At this time, I didn't realize there was a battalion of tanks. I thought it was
Watch it, folks, watch. I know it's Black 60 about.
I thought it was a company of tanks, sir, that was on our right flank.
And that strength is collective training. They can interact with their crew members, they can interact with their platoon leader, they can interact with their company commander, and it's real to them because they're interacting with all those people exactly as they would do it if they were in their real equipment.
And a commander can indicate that you guys lost the offensive over here on the left flank for the following well-known reasons. Let's back the war up and let's refight it and get it right this time. You can't do that on a range. You can't do that in a real war. You can only do it in a low-cost distributed simulation environment.
Joint operations by their very nature are complex, require a lot of ground and airspace, are inherently dangerous. So the same things that make them very difficult to do in real time make them perfect candidates for simulation.
Okay, well, they're working on the GateNet right now.
Distributed simulation technology is a combat developer's tool that hasn't been exploited as much as it could be.
Before the first nail gets pounded, you can have the user tell you what's good or bad about it. Not only can you refine your requirements, but you can also think of new requirements from your user community.
But right now we can put on a very complex battalion-level battle and have your new weapon system or your new tactical organization try to operate in that environment and see how it makes out. With real soldiers driving, real soldiers gunning, real soldiers trying to command and control your new force out there on the battlefield.
What might be new here is always having the man in the loop from top to bottom, having the lowest level affect decisions at the highest level.
Contact coming up, I think.
George S. Patton said wars will be fought by men, not machines. The virtual world actually puts that human input, that fog of war that I think is the essence of combat operations, coalition, joint, all of it.
I fly airplanes for a living. I don't want to give up my flight time for simulation. But having seen what I've seen, I think it's absolutely essential that we do this. The technology that I've seen demonstrated is more than a revelation to the military. It's actually going to be a revolution.
Eagle Troop first made contact with the enemy on the afternoon of 26th of February. We received heavy machine gun fire from a village. I ordered the 2 tank platoons to come online abreast of my tank, and we fired a volley of high explosive anti-tank rounds. When the tank rounds impacted into the village, large holes, almost the size of the entire wall itself of the cinder block building, were blown into the buildings. My role in the creation of this battle began in the desert, and I was met in the desert by a research team.
They came to us not months after, but hours after the action actually took place, so it's fresh in our mind.
We walked and drove the path of Eagle's assault from the beginning when we first fired onto the village until our consolidation point.
We spent the next couple of months painstakingly going through all of this evidence, some of which was clear, some of which was murky, trying to plot out exactly what happened.
Topped the ridgeline, saw the entire panoply of the enemy, killed 3 of their tanks,
in less than 10 seconds.
The interesting thing about what happened in G Troops area is that I had 3 separate battles going at the same time.
I troop hit a dug-in force oriented roughly in our direction, tanks and personnel carriers. The first volleys of fire were fired by the scouts who were out front.
And right now, tow launchers came up across the board as soon as that thing went up, and that thing burned. That was one of those infamous volcano deals.
Okay.
That was about the most intense time right there.
Okay.
When those first things went off, and me waiting on those tanks getting up there.
So probably no more than 6 minutes until you start seeing tanks near you.
No, less than that. Not that long. 5. I'm thinking 4 to 5.
So I was overwhelmed with the amount of work and the painstaking detail that went into recreate this battle.
This power of manipulation allows you to move in the 3 dimensions, with the 4th dimension being time. Basically jumping ahead or behind in time as well as in space, so going anywhere that one wants to.
Change the weather, we can change the Iraqi tactics, we can give them weapons they didn't have, we can give ourselves future weapons that we would like to have.
It was at that point when I saw the initial success of our first volley of fire that I ordered the troop to continue to the assault.
And he said, go tanks lead. We had it where the tanks were in a V-shaped wedge. And my scout platoon went from going from lead back behind the tanks,
providing what we call scratching fires and covering the rear of the tanks and eliminating pockets of infantry.
We tried to refight the battle as closely as possible to what our data told us the real battle was like.
It allows me to view from my perspective, from what I've seen in the battle, and to try to make it as accurate as we can recreate it.
That's true. I mean, it looked like you're looking out at your tank at the same desert.
We weren't getting anything out of some of these berms until one of my scouts shot a berm with a tow missile, and then the berm exploded.
I received a call at that point that we had reached our limit of advance.
They wanted us to stop right in the middle of it.
I said, we can't stop. It was evident that we had surprised the enemy and had seized the initiative from him.
That was not the first time that I fought a battle. I was able to fight battles at the National Training Center. I have taken platoons down these tank tables, CalFEXs, simulations, and we've also got on the ground. But if you use the training realistically, then my first battle is fought in a simulator or on a range versus a battlefield like Iraq.
You look back at what you did, and you see nothing but burning vehicles, and it's a feeling that it's deep inside that you know you've done your job.
During the battle, there was no time to feel any emotion. There was no time to feel any fear. I found myself as I watched this battle, just I could feel the adrenaline flowing. I could feel my palms start to sweat.
I was surprised and delighted to hear comments from several of the participants in the battle. That's exactly what it was like.
If you sit behind a tank night sight and you look out of the thermals, it's just like looking out of a tank.
It can take and test ideas against a set measure. So we can measure the delta. If an officer says, I can do better than that, I say, step up, son, do better than that.
It's group training at the combat level that we never had before.
We can test future ideas, concepts, tactics, doctrine, and vehicles. because we now have a benchmark that's rooted in ground truth.
So we're looking at a possibility that can really change our understanding of war.
What also is making me feel good, that we weren't forgotten. I wish I could bring my whole platoon in here and show them, say, here, sit here, watch this, because this is what we've done.
It's better than film, because film footage you can't change. This, they can. It'll probably be the most accurately recorded battle in history.
We've been moving most of the day through a sandstorm. It was a very close engagement, 800 meters or less.
So in the space of about 38 minutes, we took out 7 T-72s. I couldn't count the number of BMPs and trucks.
We almost felt like we were invincible. They could not hurt us. We knew that we were that good, and we proved it.
I felt that they should have never stopped us. The cavalry is so hard-charging that if you would have let us come, well, we would have been in Baghdad in no time.
As a junior officer, I fully understood that I could make a decision based on the situation.
The first fully interactive, historically accurate database of a military battle has now been constructed. It represents ground truth, as can best be verified by the men who fought the battle and all other accessible data sources. It uses distributed simulation technology. It is network capable. This technique can be applied to a wide variety of other military operations.
Our committee meets this morning to receive testimony and observe demonstrations of the use of modern simulation technology in the Department of Defense. For years, the department has relied extensively on computer modeling and simulation. Advances in simulation and modeling technologies are breaking down traditional approaches in the Defense Department at a time when innovative thinking is essential. Simulation has now become a key element in the training programs of all the services. It is used to develop new tactics, to design new weapons, and to test the effectiveness of those new designs. Our second witness is Dr. Victor Reese, the Director of Defense Research and Engineering. Dr. Reese has been one of the primary leaders in the use of simulation technology. He is becoming a frequent witness at our hearings this year, and we learn from him every time he appears, and we welcome you back, Dr. Reese.
These machines function to enable human beings to understand the complexity, the kinetics, the chaos of modern combat. They're no more than that. They're a catalyst for human comprehension. And we're going to use this machinery for you in various ways this morning to illustrate the verity that it is men, not ships, not aircraft, not vehicles, who fight and who win wars. If the Congress and the armed services are to address the future cogently, we must all rid ourselves of the notion that simulators are a cheap, but not wholly satisfactory substitute for flying, steaming, or driving. And I'm here to urge that we must all recognize that simulation is fundamental to readiness for war. You cannot today bring about combat readiness without some recourse to simulation. I also want to make the point with my cathartic that we are late come to wisdom in the armed services. We really did not understand combat well enough to be able to know how to affect the behaviors that would enable us to fight well and successfully until a very recent past. As a matter of fact, in the aftermath of the war in Southeast Asia.
The view that you'll see in front of you on the screen behind me is a picture of my tank at the lead of my troop on the afternoon of the 26th of February 1991. And to give you an idea of what had occurred before I got to this point here,
is as the troop was moving east as part of a regimental offensive covering force to locate the enemy's main defenses, we came under heavy fire from the village you see off to the right of the screen. And Chris, if you take a look at that, our lead Bradleys came under heavy machine gun fire, and as you saw in the previous tape, we returned fire with the Bradleys and with 9 tank high explosive rounds.
As we go along here, if you see something that you need explained, you ask the good captain to fly over there and have a look at it. And when I say fly, the fellow that's controlling all this is sitting right here with his back to you. And Chris can take you anywhere out there in time or space that you want to go. Okay, Captain, go ahead.
Glenn would like to ask.
Let me ask, where are your Bradleys and the infantry now that are falling in? Can you zoom in on those?
I want to get right up on the turret of that Bradley. Anybody that wants to look at this from Bradley point of view, from refuel, rearm point of view, from intel point of view, can pick the part of the simulation they want to study in detail.
Yeah, okay, that's what I was wondering. You're working
now
in all the different...
Now you're looking at, you're seeing what the Bradley guy sees.
All right, if you stop there, Chris. Mr. Chairman, that's the initial contact of the troop. As we crested this rise, my gunner was scanning back and forth with his turret. Off to the right front fender, he identified the first enemy tank through his thermal sights. At that point, I unbuttoned from the turret, also saw about 8 enemy tanks in revetted positions, or positions with dirt mounted up in front of them, and exhorted a little bit the 2 tank platoons behind me to come up abreast. I think it's important.
Can we see what you look like from the Iraqi position?
Yes, sir, we can. In fact, you can actually go to the tank that was destroyed.
Fly out there and look at the one that he just
from that position.
And in the Iraqi position, that's the way they defended. They had these berms thrown up around the tank. That's T-72 in a defensive position. Now, what they could see was actually a lot less than he could see because his gunner is on thermal. The thermal sight can see a lot further than these guys can see with blowing sand, etc. So in most respects, these Iraqis were hit before they knew what was out there. Here we are in Washington. This is the Washington area. We are connected with the Institute for Defense Analysis, where there is a defense simulation center. And we are connected with Vienna, Virginia, where there is a simulator for the Pioneer unmanned aerial vehicle. We are connected by long-haul communications with Fort Knox, Kentucky. I'll show you what's down there, and with Fort Rucker, Alabama. In other words, some of the pilots that you're going to see flying here ain't here, they're down there. And some of the vehicles that you'll see are manned by crews that are located elsewhere. But they're all brought here into a synthetic environment, a battlefield, which is shown here. Now this is a piece of terrain which represents Fort Hunter Liggett, California. This is the terrain that you're looking at here. This blue symbol here is an icon representing this aircraft right there. That's an F-16 Falcon. And that Falcon is today being flown by Major Pete Bonanni of the Virginia National Guard. Pete, raise your hand over there. McMaster, launch Pete. And drawing your attention over here, there's an icon that represents an AH-64 attack helicopter. That helicopter is represented by the simulator in the rear of the room, which is being flown by Chief Smokey Robinson. Smokey is a veteran of Desert Storm. He's from the 2nd 229th Aviation, Fort Rucker, Alabama. He's up here today. There's he in the picture out at in that synthetic environment out at Fort Hunter Liggett. Give the order to Smokey to get him moving.
Apache 1, Eagle 6, executed right pedal, turn 180 degrees, and prepare to test fire weapons.
You'll hear voices on here. These are coming from these distant locations or from the guys in the rear of the room. Smokey now aloft, turning toward you. Okay. Now, we have another helicopter in the simulation. That's a scout helicopter, an OH-58 Delta. This helicopter is down at Fort Rucker, Alabama. Go ahead and get him into play.
Order 1, Eagle 6, lead attachment 1 to the battle position down there.
He's been instructed to fly over, pick up Smokey Robinson, and take him into battle. Now we have on this battlefield a weapon that doesn't exist any place except in this room and except in the form of a simulator. It is the line-of-sight anti-tank missile, a very high-speed, hypervelocity anti-tank killer, a future weapon system. We're learning about it with this simulator back here, and the simulator is manned by Sergeant First Class Charles Watt. Let's get the LOSAT in play.
LOSAT Eagle 6, scan your limits of fire. Enemy reported moving towards the engagement area now.
Have him swing that hammerhead around so we can sort of see how that goes. Okay. Now we have also in play here in the battle some M1 Abrams tanks. These tanks are physically at Fort Knox, Kentucky.
Abrams 1, Eagle 6, UAV reports enemy moving into the engagement area.
We follow the action a little bit. That's a Navy Pioneer being flown from a ship off the coast of California. The ships, of course, are actually right here. And they're participating in this operation in simulation. We'll have the Pioneer return to its mother ship here. We'll get the glimpse of the ships. And these ships, of course, are under air protection. And the Navy has a F-18 up over them. He's being flown in the rear of the room here on a very inexpensive simulator. Okay, let's stop right there. This is totally unrehearsed, as you can sort of detect by the way it was going. We didn't know what was going to happen, and you never do when you go into one of these affairs. You get all of the friction of war put into your training exercises. Point number 2, we had many disparate elements. Most of our forces are stationed by type unit. Going to your point about infantry, it's important that you get infantry to mix it up every now and then with attack helicopters and jet attack aircraft. Here's a way that you can do it over great distances without a lot of time and expense.
General, can you maneuver your enemy also?
Yes, sir. The enemy is under intelligent control, and that's a very important point that Marshall came on very early in his career. You gotta go up against not cardboard targets that can't shoot back, but against a thinking enemy that's trying to do you in. And that's what is going on here. We could increase that enemy force virtually at will. So we can raise the odds. We can endow that enemy with technology like thermal sights and see whether that makes a difference in the battle. We can, in fact, change any of the parameters in this thing very inexpensively and try out new ideas, whole new combinations of putting forces together.
And you're saying that we have tremendous potential here in the joint arena that has not yet reached its anywhere near its potential.
That is entirely correct, sir. I would propose to you that, in fact, what the chairman needs is an alliance with a technological expert comparable to the sort of service that is provided to chiefs of service by their head of materiel command or whatever. And I don't see any alternative in the Department of Defense than an alliance between the chairman and the Director of Defense Research and Engineering to bring that sort of thing to pass.
Mr. Chairman, about a year ago, I asked Secretary Cheney what he expected from the department's technology program. He replied that the technology that had made such a major contribution to the victory in Desert Storm was not his technology, but had been developed by his predecessors. dating back to Harold Brown, Jim Schlesinger, and even Mel Laird. What he hoped would come from the current technology program was that if some military operation was necessary some 15 years from now, it would be as successful as Desert Storm, and people would look back and say that the Cheney Defense Department had also provided some outstanding technology. Those were my only marching orders, Mr. Chairman, and I believe that the key to acquiring that technology, as well as training the type of forces we need, lies in the distributed networking simulation that we've discussed and demonstrated today. And the reason for this is simple but profound. Network simulation is a technology that elevates and strengthens the collective problem-solving abilities of human beings, people acting as teams, learning and getting better. And this is true whether they are design teams, manufacturing teams, education teams, training teams, acquisition teams, or warfighting teams. Network simulation with modern information technology can connect people together in an aligned, coherent, integrated enterprise. It is at the very heart of the department's technology strategy. Captain McMaster's team used this technology to do it right the first time in Easting 73. If we have the wisdom and courage to do it right, I'm convinced we can all be as successful as the 2nd Armored Cavalry. We can all be Top Guns.
On that note, we will close the hearings, and I hope everyone would, in the audience would feel free to take a look at the exhibits, and we'll spread the word, make sure all the senators know about it. Hopefully we'll be able to come by. Thank you very much. Thank you.
It will not acquire a target under 500 meters. The left-hand trigger is like 67 meters away. The left-hand trigger is laser.